Okay, the next step is now we have both of the numbers separated, decimals and singles, and we can move them around as we want. But the problem is that we have two different loops. So what if I want to send a 56, for example? I cannot just go send my programs, put a 56 over here. I'll have to loop through one and loop through the other one until I get that 56 number, right? Or I have to separate that 56 number into two different digits, and it becomes a mess, right? So what I want to do is create a third table. Let's edit test, and I want to create a third table that it becomes the pairs. So this is the single units, this is the decimals, and I want to make a third table that is basically going to be the sum of both of them. So for this, I'm going to create a table called, I don't know, pairs, right? PRS. So let's pairs, open curly bracket, close curly bracket, and then basically this thing has absolutely nothing here because we're going to populate it later. All right, now what I want to do is add a value to each one of those possible pairs from 0 to 0 to 99, right? So how are you going to do that? Well, basically we're going to be using the same thing that we're actually using right now. This thing right here is going to help us. So we are going to add a value to pairs. Now, we need to be adding another value to pairs. So let's see. At the end, we're going to be adding pairs to next value would be k. Let's just say k. Pairs of k is equal to obviously the sum of the units I plus the decimals j. And this can be done backwards. I mean, it doesn't really matter. It's going to go through everything anyway. And it's going to be adding it over here. And then after that, we need to add it a next one over here. So we're going to start up the value k with 1. And then after this is done, we're going to add k is equal to k plus 1. So basically, every time that goes through here is going to add a new value to k. Does it make sense? Now we're going to take out this sleep because we don't want this program to take so long to start. There we go. And basically this will go really fast and just populate k. Get it? I hope you guys get it. So it will k1, a1, it will just add the numbers. And at the end we will have pairs k from 0, 0 to 199, and then we can just send that output. So let's say after this is done, let's say redstone set foundlet output on the right side, and I want to turn on the number, a weird number, 38, not 36. There you go. 36 is not a possible number that I used to send, right? I used to send just these numbers over here. But it's not 36 by itself, right? It's pairs, right? So pairs 36. Let's see what pairs 36 actually gives me. So run test. And boom, immediately went to pairs 35. What happened just there? Well, if you guys remember, we start with a 0. So 1 is actually 0. Does that make sense? So the unit that I got here for a 6 would be, oops, the unit that I have over here for a 6. So this is unit number 1, which is a 0, 2, 3, 4, 5, 6. That will be right here. How's that? Does that make sense now? So what if I want to send the 0, 0? Let's see, I just want to send pair 0. Let's see what is that value in there? Well, that's going to give me an error because I never save it 0, 0. So what if we start the k from 0? Well, there you go. 0, 0. Now that we started decay from 0, we can give a value to 7. If I just turn on 7, it will be 0, 7. There you go. Now let's turn on another value up here. Let's say 67. 67. Perfect. So now I have this one on this side. And what about this side? Well, if I copy the same colors from here to here, guess what will happen? Just guess. Just take a wild guess. White, orange, magenta, great, light blue, yellow, lime, and pink. There you go. And then we start with, I believe, yeah, right here. After pink, it was gray. Well, you can actually see it, right? And then light gray. Is that gray or light gray? Yeah. And then cyan. And then purple. And then blue. Right after purple. And then brown. And then green. There we go. So what's going to happen? Same computer. I'm just using the other side of the output over here. I'm using right for this one. So if I do right, that's just a number. There we go. Let's say I just go do left. And then just run test. Ta-da! 67 on both sides. Perfect. How's that working? Now we have a way to put the numbers up there, which it shouldn't be that hard if you are patient, but if you see, it doesn't really take us that much time. Now we have 67 and 67. The next step would be actually populate this with an actual number. So for that, we're gonna go to the HTTP API. All right. Okay, now we're back with the final part of this thing, HTML. So to send a number there, we get it, right? So if we were to do just a simple OS time, then we can just send the time over here. It's separated in minutes and hours, and that would be super simple to do. But we want to make something more cool than just that. So I'm just gonna leave that as an example and just leave it right there. Boom. HTTP requests. This is gonna be the coolest thing ever. All right, HTTP request is gonna happen like this: HTTP.request, and we're gonna do a request. Let's just do google.com for now and see what that throws us back. Now, for these, we're gonna have to wait until we get a response. If you have fast internet, slow internet, if the server is not responding, etc., we need to have a response from this. So we're gonna be having a while true do, and it's not gonna exit this until it gets a response, an answer, right? And it's gonna keep repeating this. While true is basically while this condition it's true, then keep repeating this, and true is basically an answer to the condition. So while obviously it's true, it's like what meantime if one as long as 1 equals 1, keep doing this. So obviously forever, right? So while true do, that's what it means, do this forever. But we're gonna break it. once we get the result that we want, we're gonna step out of it, and we use a break command to get out of there. So we're gonna be using a pull event. These events happen when anything happens on the computer. If you get connected a redstone signal, if you right click it, if you turn on something, if you send a RedNet message, a wireless, a turtle, I mean anything that happens with the computer, a right click on a monitor, everything becomes an event. So we're gonna be pulling at that event. And these are two specific events that could happen in this computer. And for this, we're gonna save in these variables: event, and then URL, and the message. You definitely don't need to use this variables, but you can if you want. I'm just trying to make it more understandable. So, and we're gonna call OS pull event. There you go. Now, there's gonna be all kinds of crazy events here. So if the event name is equal to HTTP underscore success, then end, or actually instead of end, else if. Else if, it's a combination with if. Usually if ends with an and, but you can add this one right here. So if this is this, or if it's this. So it's either or, right? So else if the event is equal, and you put this, this is just a text. If it's gonna send a request, and if it gets exactly this answer, then it's gonna count to this. HTTP failure. Then, okay, and do something else, right? So if it's a failure, so if we don't get an answer, then obviously we're gonna something like, I don't know, print no connection, and then break, because we already did a request and we already got an answer, right? So what if it actually happens, the success? Then we're gonna grab the message that we get, and we're just gonna print it, all right? So if it's successful, then we're gonna print the message, and let's see what happens. And obviously we're gonna break. Test, and 51 unexpected symbol. Okay, here we go. 52, 51, oh. And I bet everyone saw it except me. And attempt to call negative. 44. Request. Gosh. Yep, no, that's me. That's me. I always make this type of mistakes. Invalid URL. Okay, yeah, I get it. I get it. It wants the HTTP thing over here. HTTP. How's that? Okay, another complaint. There you go. It returns me a table, which means there's a lot of information in there. Okay, let's see what that table gives me. So if we get a table, that means that the message is a table. This one over here. So what we're gonna be doing is getting the message to be printed. So we're gonna be message dot read all. Let's see what this gives us back. And there we go. So this may look crazy to you, but this is actually just Google. It's the most common thing you can ever find in Google, actually. Let me just pull it out over here so I can show you guys. There you go. So if we come over here, Google, google.com, if you right click and look at page source, if you see the page source, you're basically seeing exactly the same as we got over here. You see maybe the script and the spine and the head, the body, the class, all this stuff that we got at the end. It should be like all around here. The event listeners, the target, the element by name, everything over here. You see the Google. All this is what actually makes your website run. So this stuff over here is basically the source code of this thing. And that's when you go to an Explorer and send this, it's basically you're sending an HTTP request and you're getting that answer back. So let's go for that time API website. So in API, there you go. This one, it gives you a couple of examples. If you do this, UTC/now, it gives you basically just that. And if you go to see the source code, it's just that. It's a clear number. It doesn't have any codes or anything else. And it also tells that you can format it. You can format it, and format it will be like this. So that's a pretty cool thing. You can format it this way as well. You can put all these commands over here and just give yourself a format. So by using this, I figured out minutes are counted as one of these, I believe, and M is hours. How do I know? Well, let's just see. First of all, I am not on UTC time. I'm actually on PST, and that still works. Gives me my time. Yep, it's 5:41 p.m. So I don't want Monday. So probably if I take this out of here, Monday is gonna be gone. There you go. Percentage 25B, that would mean February, maybe. So I take it out. There you go. So there you go. This 17 will be 5 p.m., right? So D and I. There you go. 5:42. That's my time. So I need the I as the hours and the M. And it seems like I could do, because it's not no, this is the 17th day of the month, right? It's a day, it's a D. Okay, so I need the I and the M, and I don't care for none of that. Now what if I only want the I? There you go, percentage 25 I, and I just get 0.5, which is my hours. Okay, perfect. Let's see if that actually works. Edit, test, and we're gonna be putting that address over here. So we got, I'll probably just copy paste it. I hope it will copy well. Paste, and I'm missing the HTTP. Format. Something happened there. Oh, this is actually space. It shouldn't go there. It doesn't matter really, but just to keep it clear, it's just like that. So percentage 25I means the time. And it's going to print the message, read all. It's going to print whatever it gets. So let's see what it gets. There you go. Got a number 0.5. Is that cool or what? Now, what can we do with that? Well, right now, we can print it somewhere in a monitor, on a screen, or whatever you want. You can just grab the number from there and just print it on monitors if you don't want to make the whole display that I did. But what fun would that be, right? So we get a 5 for the hours. This means this goes on the left side, I believe, right? So let's just actually save it on a variable for now. So we're gonna make it, save it over here in hours. Hours will be equal to whatever this answer is. But I don't want it as a text. So I want it as a number. So to number. If you do to number, it will convert any text into obviously a number. And that will save it on the variable h. So h from now on will be actually not 0, 5 in text, it will be just 5. There we go. And that will be the ending of getting the hours. And obviously down here, all the way down here, let's find out a place for it. And let's say if h is different, that's how you write different, the comparison. Then nil, then nil is like a null number, like basically it says if h is different than non-existent, or if h is something, right? Then rs set bundlet output left, and obviously we're gonna grab our PRS for the pairs and put the value of h in there. So if it's different than nothing, then go ahead and put it on the left side because that's where the hours go, right? So let's see, test. Boom, 0, 5 right there. So now let's go do the minutes, and that will be pretty quick. Edit test, and all we need to do is another one of these things. So it's not difficult. http.request http semicolon / www.timeapi.org pst now question mark format equals percentage 25. What was it? M, I believe. Let's see. Let's just, yeah. That will be 47. That's 47 minutes right now. Perfect. So that will be capital M. Remember, capitals are important as well. And then while true, do end. And that's right there. And then event URL message equals OS pull event if the event is exactly the same as HTTP success, then, and we already know what's going to happen over here, M for the minutes, right, is equal to number message dot read all break else if event is equal to a failure or an HTTP underscore failure, then print. I mean, you can be more specific, like I couldn't get the minutes or whatever, but no connection will be enough for me. Break. There we go. Now we got the minutes and we got the hours separated into different ones. We just tested the hours, so we know that actually works. And now we go, if M is different than nil, then go ahead and send the output. Say rs set bundlet output to the right side, the pairs of minutes. There we go. Let's test it out. And there we go. 0549. It just actually turned right now. So now how can we keep this running? Of course you can. Edit test. Now we're basically just gonna have to do a big while through do loop whatever. So up to this point we already saved our new PRS. So this is what we need to be repeating. Now we're gonna be doing while true do, and this is gonna take their own time. So you don't really need to put like a loop. What is it called? Like a sleep. So you see, I put the while true do. So basically, just repeat whatever is coming up next, and I go all the way to the end, and I put an end. So basically, everything over here becomes part of the middle. So it becomes inside oops, that big while through that I did before. There you go. And that's just for arranging purposes. So now, if I run it over here, there you go. It's actually just in time to change it for 50. So as you can see, it will actually keep changing. And this is my actual current time, 0550. That is my real time in real life. So there is no more Minecraft time days that if it turns to night, it becomes weird hours or whatever. This is an actual cool thing to have a real timer in your base for real-time Minecraft time. Now, what if you want to do this on and off? Just for the laughs and giggles. Well, the on and off usually it only tells you that little blinking thing. It only tells you that it's actually working. So we're gonna do it really easy. It's basically just in an output in white, right? So we're gonna be doing a variable. This is gonna be light on equals to true. So when it starts, at the end, it's gonna do this. rs set bundlet output. Actually, instead of making it all that complicated, equal to 1. Here you go. And then we set the output to the top. And we put the output as 1, right? Because 1 is white is 1. Cool, we're cool with that. So we're not going to put the output as 1, we're going to put the output as that thing that we have, light on. Light on. There you go. Whatever is light on. And then down here we're going to say if light on is equal to 1, then light on would be equal to 0. So the next time that it comes here is going to be 0. And then when it becomes 0, if it's not 1, then else light on is equal to 1. So basically every time that comes here, it's going to check if it's 1. If it's 1, then it's going to make it 0 and get out. And then next time it's going to come, it's going to be a 0. And if it checks it, if it's not 1, because it's 0 already, then it will make it 1. Pretty simple, quick, and dirty solution. And hello world. Where is that at? 44? Yeah, obviously. I'm not comparing. I'm actually setting it an equal. So yeah, that was my fault. So there we go. Now every time that checks the hello. Why it's not working? It is 53 right now. Oh, there you go. So I guess it just took a little time. There you go. Now it's blinking. I mean, it all really depends on your internet connection and how fast the server is going to be answering. Now it can go crazy because I don't have any delay, so that is a pretty bad thing. You see how it actually changes? This is the actual speed of the checking in. Every time that this changes the state, it will be I just finished a request. So all these are requests that this computer is sending. So the server can get crazy if you start to send too many requests at the same time and too fast and whatever. So you rather put like a little delay, which it wouldn't hurt really to put a delay. And that's why I didn't add seconds. I mean, it's easy as to make another pair of this and you can add seconds over here, but I would not recommend it to add seconds because it will be too stressful on the server. And once the server blocks you from requesting, then your whole freaking neighborhood is going to be blocked. So just put a sleep there and let it sleep, I don't know, for 1 or 2 seconds, you know. It wouldn't hurt, just like let it go for a while. So there we go. Now that will be more calm, more easy, will not freak out, and the server would have relaxed, and you still have the times like maybe 1 second delay, which is not bad. There you go. So now you can set up a time for like a specific time, maybe at 8 p.m. I need to do my homework or whatever, and you can set an alarm in the computer to maybe send an output through the back or to the bottom. I mean, we still have other outputs from over here. So obviously we can set up this from the side, and you can put another output over here, you can put another output down there, and you can make it control all kinds of crazy things. So I guess that wraps it up. So I hope you guys enjoy it and learn something and get inspired and stuff like that. I mean, I really wanted to do this, and it was complicated, and I ended up even doing a freaking, I learned to do Objective-C programming so I can do this little application for me. And as you can see, it's actually pretty fun. It's not perfect. I mean, I can grab one of these and pull it all the way up here, which I was not supposed to, or pull this one around here. So it's not a perfect application, but you know, it's kind of cool. Whoops. So yeah, and then if I hit clear, basically all the red dots that I put, they will clear it, and if I put reset, it will bring back all of them into the arrangement down here. So this is another cool thing that I did. And I was just inspired. I basically just went actually to the school library, and I just grabbed a book of Objective-C, and I started reading about it. I download Xcode, which is free, and I started doing all this programming and stuff. And yeah, I mean, it's not complicated. All the information is there. The truth is out there. All you need to do is actually go check it out. And now I'm looking at that 5 back there. What's going on with this lamp right here? That is a funny lamp. Oh, okay. So it's because of the mode. There we go. That freaked me out. Alright. So yeah, well, I was saying, you guys can put this on your base or show me what you can do. And if you guys want the code or not, you know, I don't think I'm gonna put it up there. I think I'm just gonna have you guys just go through the video and copy it and type it yourself, because that's the best way to learn, when you type it yourself. So until next time, this is Angel Malo signing off. See you later. Bye bye.